So now that we've gone over the basics of logarithms, I want to see if we can figure out what this thing's graph looks like. And we're going to use really the same approach here that we did when talking about exponential functions. We're just going to plot some points and see what we come up with. So I'm going to do this using the log base 2 logarithm. Really doesn't matter which base we use. It's going to be the same sort of situations that we saw with exponential functions. Changing the base, it changes how quickly or slowly the graph increases, but it doesn't change its basic shape, right? So we can pick basically any base just to get an idea of what that shape is, and I happen to pick 2. All right, so let's start filling in some values here. The log base 2, I'm going to do the integers first. The log base 2 of 1. Well, 2 to the 0 power is 1, so that's going to be a 0. And I'll go ahead and plot that point. All right, log base 2 of 2. Well, 2 to the first power is 2, so that's going to be a 1. Right, that's going to give us this point. If we do 4, 2 squared is 4, so the log base 2 of 4 is going to be 2. And the log base 2 of 8, 8 is 2 to the third, so that's going to be 3. And there's our points. Okay, that's kind of starting to get an idea here. Now, how about if we do the fractions? Okay, the log base 2 of 1/2. Well, if you think of 1/2 as 2 to the negative first, then the log base 2 of 1/2 is going to be negative 1. Log base 2 of 1/4, that'll be negative 2. Because 2 to the negative second is 1 over 2 squared, which is 1/4. And now it's going to start to get a little tricky to graph these because they're really going to start to get squinched pretty close together on the x-axis. So just kind of bear with me on where these are getting positioned. The log base 2 of 1/8. 1/8 is 2 to the negative third. So that's going to be negative 3. And there's our last point. And that's pretty good. That I think gives us a pretty good idea of what the function is going to look like. Now, one thing we do need to add on here, this function does have an asymptote. Remember, the domain is non-negative real numbers, which means we can never cross over to that left-hand side of the y-axis. So we're going to have an asymptote here at x equals 0. Now, I want you to contrast this with a graph of an exponential function. Right? The graph of y equals 2 to the x looks like this. And of course, we have the asymptote here. Right? So you can kind of see the flipping that took place. The exponential function goes through the point 1, 2, where the logarithmic function goes through 2, 1. The exponential function goes through 2, 4, where the logarithmic function goes through 4, 2. And the asymptote's also switched. The asymptote for the exponential function was y equals 0, and the asymptote for the exponential function, the asymptote for the exponential function is y equals 0. The asymptote for the logarithmic function is x equals 0. So you even have the x's and y's getting reversed in the asymptotes. Okay, so I'm going to just summarize a few of the things we've seen now. The domain is non-negative real numbers, and the range is all real numbers. We saw the x-intercept of the graph is 1, and that is going to be true of every logarithmic function, regardless of the base. And there is no y-intercept. Again, I know you're going to get tired of hearing me say this by the time we're done, but contrast that with the exponential function, which was the other way around. It doesn't have an x-intercept, but the y-intercept is at 1. The y-axis is this vertical asymptote, and the graph is what we call smooth and continuous. Okay, so let's take a look at an example here. I want to graph this function, log x minus 1 plus 2. Well, I need you to, again, just like with the exponential functions, think back to those transformations we talked about. Right? What I have here is just our base graph, y equals the log of x. The x minus 1 shifts this graph 1 unit to the left, and it shifts the whole graph. Notice how the asymptote moved along with it. Right, so the asymptote is now at x equals 1 rather than x equals 0. Then we're going to do the plus 2. that's going to shift everything up to, and that doesn't really make a meaningful change in the asymptote, right? Only a vertical shift will change where that's located. And that's it. We've done both transformations, so that's what our graph is going to look like. Okay, so let's take a look at this one. Now we've got three transformations going on here. We've got the -1, we've got the minus in front of the logarithm, and we have the minus in front of the x. All right, well, what I've got here is the base graph. This is just y equals the log of x. And I need to do the transformations one at a time. Well, you need to do the minus log or the minus x first. It doesn't matter which one. If we do the minus log first, that reflects the function across the x-axis. So it's going to turn into this. Now, if we do the minus in front of the x, that reflects it across the y-axis, and we get this. And finally, the -1, that shifts the graph down 1 unit, and there you've got our final result. Okay, so a couple things to point out here. Yes, this function is defined for negative x values. That is perfectly okay. At no point would you be taking the logarithm of a negative number, because that minus sign in front of the x is going to take any negative x value you put in and make it positive, right? So in the end, you'll be taking the logarithm of a positive number, and that's a fair ball. So if somebody were to ask, what's the domain of this function? Right? I would say the domain of this function is all non-positive real numbers. It's the numbers from negative infinity up to 0, not including 0. And the asymptote didn't move. Right? The asymptote stayed right where it originally was on the y-axis. Okay, so what's next? These logarithms, they have some really unusual properties. So some unusual relationships between them that are super useful when we're trying to solve both logarithmic equations and exponential equations, right? So it's those properties that we're going to take a look at in the next lecture.